So I'd say we just start. Gokul, if you're hearing us, make yourself visible or noticeable. We don't hear anything yet, but I'd say we just start where we stopped the last time. I think we just started with asset modularity and instancing, right?
Yeah, we did exercise.
Yes, yes. The first exercise, right?
Yeah, yes,
This one.
yes.
Are there any questions so far in the meantime, in the last week you wanted to raise?
At the end, it did work.
What?
At the end, it did work in the last session.
Yes.
Yeah.
Yeah, let's maybe just look into that as well. We saw that. Did we do that? I'm just, my brain is like
Instancing, yeah.
rotting.
Yes, okay, yes, to some.
The instancing?
Yes, yes. This was the last.
That one, right?
Yeah.
So let's continue with what is instancing, right?
Okay.
Or did we do that as well?
We finished in the example. I don't know if this did work for everybody.
With that, right? Yeah.
Yeah.
So let's see. I'm sending right. I think yeah, that was just like the very large scenario. Spend some time exploring the folder and asset structure. So yeah, just to get you started as well, we need the zip file here, asset modularity and instancing exercise content. Just put that for if you don't have that in the chat, and we extract that to I already did that right last time, but I'm on a new first PC instancing to our USD root, right? Here it's instancing. Here are all the examples. Okay. And as always, we have to activate our Python environment. Let's do that as well. And so here we got it. Great. So what is instancing? Very important concept because it helps us to really yeah, make optimized scenes. Yeah, exactly, especially for digital twins, because normally a digital twin of a factory are a lot of yeah, similar objects like containers or, well, parts. There are a lot of things in the factory, right? Racks, shelves, like that. Instancing may be familiar to you from other applications or contexts. Yeah, in this lesson, we present the concept of instancing at a high level to serve as a foundation. Yeah, foundation would be helpful for later lessons. And yeah, there is something USD specific about instancing, scene graph and point instancing. Yeah. So we have a scenario, right? We have a facility with just a warehouse, and we have lots of different references on this rack, for example. So we start with refreshing the concepts of composition. Yeah, we reiterated the composition concept. We have our local layer stack, and then the composition arts that compose content into the local layer stack. Yeah. So scenario, robot, a few instances of the robot. Layer functions as the point of refinement for all the content you've composed. What's going to be articulated, assembly line, simulated. Yes. And we also use variants. Sparse overrides, also known concept, and one superpower of USD, right? Assemble and continuity refinement downstream. Encapsulating your assets and modular layers, right? We want to have it modular. Use things, we get a lot of flexibility, and so on. Overrides, post composition. Right, times may be able to detect whether attribute values or parts are the same, but as a form of data deduplication. Yes. Yeah, yeah. Anything like, yeah, here, that's a nice example, right? You have like the same element, but you override some elements after referencing it. Making this blue, this red and green, and also changing just a single piece of the asset.
Oh, how do you change the single piece? So you turn it off in an overlayer and then you replace it with another?
Oh no, you reference it and you like then over just set the different part. I mean, yeah, we can try, but I think should be in an example also. No. Yes. It says data deduplication is free, and you have to see in memory if if things are really different, right? It would be nice to be able to say upfront that a particular scene element is not open to refinement. Yeah, this is instancing. Then that's a good explanation. Yeah. So if we already know that we just want to use this blue robot a lot of times, that's the case for instancing, right? And not just referencing and sparse overriding stuff. See? Instancing is a declarative deduplication of modular repetition. Yeah, we're going to say we're going to limit our per instance customizations and share the composed result among the copies to create a fast and memory efficient view of the scene. Yeah, it's basically just take it, duplicate it. Right. You can see, yeah, that's a big performance boost because you don't have to re-evaluate the whole subtree, but just like reuse what is there. Yeah, that's a good example. 3 and 4 instances, assets in this case, yeah, yeah, then we just have one element which is just instanced, you know. Sharing data through layers, yeah, we can deduplicate repeated modularity to reduce the runtime resource usage. Instancing accelerates the performance of, yeah. Should go through and check each and the Robinson, yeah, instance, yeah. Yeah, we say upfront, this is identical. We want to reuse it. Don't care about like some changes in the subgraph, basically. Yeah. Any questions so far? Or there are basically two separate kinds of instancing, which are both very valuable. So we can go into that. Scene graph instancing. Learn how to create and manage scene graph instance in USD. It's an instancing hierarchies here. What will accomplish? Explain how. Yeah, makes sense. Instantiable metadata. Analyze stage statistics to understand the performance impact of instancing. Implement nested instancing hierarchy for complex scene structures. And compare the performance.
Okay,
yeah,
so
makes sense.
We've got scene graph instancing and we've got nested instancing. Is that
No,
correct?
point instancing.
Point instancing. Okay.
That's so instantiable is one method by setting this attribute, and the other is point instancing. That's
okay, which is coming.
Okay,
good. Okay, good.
So first, scene graph instancing. And implicit prototypes, exactly, and composition arcs. Yeah, makes sense. Scene graph for native instancing is the first implementation of instancing in OpenUSD. Then we'll look at scene graph instancing is the core feature of OpenUSD that turn prim hierarchies or subgraphs into prototypes that can be shared by multiple copies within a scene. That's valuable for large-scale scene. Yeah, digital twins are core domain, architectural visualizations, and ASR where you need to represent many identical objects efficiently. Yeah, makes sense. And here, yeah, that's prototype is a key term to know, and the instance, right? So prototype is what gets like copied or instantiated. And the instance is basically what you see.
Okay, it says on the prototype, it says prototype 01, and on the instance it says robot 01. Where does the robot 01 come from? The name.
Oh, that's basically the prim name in this case. No, just
so you rename it by hand then, or is it? No, you don't.
That's the USD name or prim structure isn't affected by that. It's just since you specify, and that's probably what we're gonna see now. Since you specify this instantiable attribute, it just USD knows this is basically an instance, so it knows it doesn't change anything in the subgraph, right? But you could name this as you want. It's just for clarification, I'd say. Right. Prototype is a unique shared substructure. Instance repetition of a prototype is in a scene. Instantiable prim or instance prim, the mutable root of an instance. Instance proxy, a read-only addressable stand-in of the prototype prims of an instance. We will see that in the upcoming pages, I'd say. Above, we have a robot with a gripper, arm, and base. Arm and base, yeah. We may have an instance of that prototype. A repetition of that prototype is a scene. The mutable root of the instance, robot 1, is called the instantiable prim. Lastly, the instance contains instance proxy, so we can query robot 1 gripper. To learn more about what type of gripper the robot is using without having to map the underlying prototype. Okay, how does it work? To enable scene graph editor, you need to set 1 milli, the instantiable prim metadata. That's what I said. Yeah, and if as soon as we set this to true, we know, okay, that's basically an instantiable. And we want to have a shared version. And this shared version is the prototype, right, of an object that many instances can use as long as they share composition args. Whereas it's two references to robot arm with instantiation enabled. To use the terminology we just introduced, it should generate one prototype and two instances of the prototype because the two robot arms are using the same reference. So let's see. So here is our scene, right? We have our warehouse, we have robot arm 1, robot arm 2, references the same USD file, and here we say instantiable true. It means, yeah. These are basically using the same shared prototype. And now we have another conveyor, also instantiable. So let's see what's about that. Setting instantiable true is an explicit signal that USD should use instance, and it basically says we're not going to put sparse overrides on the descendants of this prim. So anything below that we won't change, right? And we also can't be, I'll open it afterwards in Omniverse, then you will see that the scene graph below is not editable anymore. Functions and instance subbars are immutable, but instance, yeah. So yeah, this is still mutable, basically, right? It has to be. If you couldn't edit an instantiable prim, we could move our instances around and all of our robot arms would be on top of each other. Exactly, because that's exactly what's happening here. So we can still edit this prim, but anything below we can't, right? But since we want to move our robot around, we still need to be able to specify like the translation of this instance. That's what's meant with that. For its logic, it's natural to make an instance prim allowed to have any arbitrary overrides you want, but just on the instantiable prim. And so, do you think there could be a problem with that approach?
So
for robots.
So the tricky part here is that we are instantiating the entire robot, not a part of a robot, right?
There you go.
So yeah.
So we can't move it, right?
So you can't actually.
We can just move the whole robot, but since it's completely instantiated, yeah, we can't move the arm.
Okay, so in order to animate the robot and to simulate the robot, you'd have to rip it apart, and then instance every single bit. Oh man!
I think that's what comes now in the following section. Let's see. So let's see what comes up. Yeah. But just on the instantiable prim. So then the conveyor prim also has instantiable. Yes, OpenUSD would create a prototype for this subgraph too. But based on the snippet, we would infer that there is only one instance using the prototype. Yeah. So explicit instances, implicit prototypes. A common experimental in learning about scene graph instancing is explicit instances, implicit prototypes. You tell OpenUSD the candidates for instancing. It figures out the prototypes implicitly from the authored composition args. So you don't have to say, this is actually the prototype and the other things are the instances, but USD determines itself, right? So as soon as it determines is this basically the same and does both have the instantiable attribute set to true, then it like figures it out.
So wait. So you say OpenUSD is doing that, or Omniverse is doing that?
No, that's an OpenUSD thing.
Okay, but how is it doing this?
Look in the source code.
Okay.
So it's basically the, yeah, you know, it has a, basically a prim has a certain signature then after all composition arcs have been like evaluated, right? And then if it can determine that it's the same, then it can instantiate it, or yeah, use like the instance. No.
Okay, so if I export an assembly line with the same KUKA robot, yeah, and I get it as a step file, and all the heritage and everything is not there anymore, and I have to transform it, get it in there, and then I have 100 KUKA robots. And when I'm importing it, then within OpenUSD/Omniverse, it figures out this robot is the same, and then it asks me whether I want to instantiate it or no.
No, that's something you can specify at the importer, as I recall. It doesn't do it automatically because yeah, it depends on your scene, right?
During import, I can tell the importer to instantiate if possible, so to say.
Use instantiating. You can also do this, for example, with a Blender exporter at export time. That's kind of a option of the GCC basically.
Yeah.
So we will start with our warehouse stage before instancing. What it would yeah. In the prototypes, in this case, correlate with the 4 assets we created beforehand: robot, arm, rack, pallet, and box. Yeah, probably. Maybe I'll just open the file, huh? Where is it? Let's say it should be here, right? Where did we get the file? I'm a little lost. Oh well, it's gonna come. Yeah. Ah, there we go. So let's see. Why instance proxies? SyncGraph instance should be thought as an opportunity for optimization, but it's not a mandate. Yeah. Instance proxies provide a convenient way for end users to see what an instance is made up without having to follow the interaction from instance to prototype. Additionally, a script or tool that reads OpenUSD data is not performance sensitive, can ignore instancing altogether. Okay. So it's basically just the optimizing the rendering, for example, right? So you can basically enable traversal of instance boxes and read the OpenUSD data as if instancing was not enabled. Yeah, you basically, if you traverse the scene, it doesn't make a difference just from the information kind of, right? Enable traversal of instance boxes and read the OpenUSD data. Yeah, you don't get the performance benefits, but avoid some added complexity in your script. Yeah. So here we have an example. To drive home the points of how instancing works in OpenUSD, here's a quick puzzle. How many prototype and instances would be generated when you load the stage? So what would you say? It's a trick question, so. Any idea?
Just one. It's going to be overwritten in the sequence.
Yeah. Composition arcs. There is no composition arc on the instantiable prim, so it's nothing to generate prototypes from. Obviously, that's great that you want to instance these, but I'm not going to do anything here because there are no composition arcs for me to derive prototypes from. So, yeah, okay, yeah. We don't have anything here in as a subtree? Yeah, so that was a trick question. So basically, you know, because we if we would have a reference in here, then it would create like these instances, right? And here it doesn't do anything because yeah, we don't have any content which would have to be instantiated, right?
Can you go back to the other so that we can see the
here. This is missing basically, right? The references.
Yeah, reference. Okay,
right?
Yeah.
So we don't have any subgraph, and it doesn't need to like do anything. That was a.
Can you go to the other again?
That question.
Okay, yeah, no
See?
reference.
See? Yeah. Makes sense. Yeah, that would be something also for the certification probably. Yeah. That's really a trick question. Yeah. Yeah. That's why it's important to understand the difference between edits on a local layer stack versus edits through composition arcs. Yeah, and in this case, it's the referencing arc. Yeah, good point. So scene graph instancing. Any questions from the other guys? Thank you, Marcus, for trying. Yeah. Scene graph instancing in OpenUSD provides a powerful optimization tactic for large-scale scenes by creating shared prototypes from repeated subgraphs. Repeated subgraphs, that's basically the important thing. Instantiable metadata enables this functionality, allowing your OpenUSD to automatically generate implicit prototypes from explicit instances based on composition arcs. You know, understanding the Keytron prototypes, instances, instantiable prims, and instance proxies is essential for effectively implementing and managing scene graph instancing in production workflows. Let's go to the exercise and try that, right? Component assets and measure its performance impact. Use a Python script to toggle instancing, observe how instances and prototypes appear in the USD view, compares data times to, yeah, that's also a big thing, right? Startup times. You don't want to have your scene like loading forever and then displaying something when it's done. So you want to make this as fast as possible, right? Yeah. Well, that's doing number of variables, blah 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 blah. That's internet performance and using English from measure performance. We're on the USD measure performance script, including with OpenUSD. I'll open that in another tab. Oh yeah, there is a whole tool for that. But we can then try. Okay, so let's start by opening a warehouse scenario where we're enabling instancing. Run in the terminal. We want to open our XCAM1 with the scenario. Let's try that. Loading that. Just loading up. So the window already appeared in my other screen. It isn't reacting, probably because it's such a lot of elements. Yeah. So that's how it looks like. Yeah. Yeah, there are quite some elements on it. It's here. Yeah, that's basically then the geometry, but you have a lot of pallets in a lot of racks with a lot of boxes. So that's quite, but it's a typical warehouse scenario. So actually quite a small scenario. So if you look into warehouses. Have you seen the Keon use case of NVIDIA Omniverse? I'll look it up. That's a real large warehouse scene.
We'll do it, Mickey.
Oh yeah,
I'll do it.
Can you look it up? Yeah, that's
Yeah.
good. Thank you. So yeah, so what do we have to do that? We launch USD with camera XCam1. Let's select the camera named XCam1. Yeah, makes sense. Camera, select camera XCam1. Let's try that. Where is it? Camera.
At the top.
That guy, right? Camera. Select camera. That's what it said. XCam1.
Yeah.
And here is basically the camera, right? Makes sense. Click on the bottom right of the panel. This will open the Prim legend drawer. This legend indicates that single of instances have light blue text and prototypes have dark blue text in the tree view. Yeah. So let's do that. Question mark. And it says, okay, we have args. Makes sense because it's a reference, right? And we don't have any instances right now. Yeah. Good. Click window interpreter to open the interpreter window. Run the following code in the interpreter window. Yeah. Window interpreter. Yeah, that's kind of a Python environment inside USD view. Right. Run the following code in the interpreter window from pprint starts USD util something. Let's do that. Let's see what comes up. I copy it. I paste it. Asset count, instance model count. Active prim count 44,000. That's quite something, right? And we don't have any instances, so that should change probably, right? Yeah, we've just seen that. These are useful overview. We will focus on total prim count, total instance count, prototype count. To understand the impact difference of different modifications we make to our stage. Here's a summary of the stats so far. Exactly, just as we observed. So let's close that. And run in the terminal measure commands. Yeah. Interesting. Measure command and time are being used to measure how long it takes to execute USD view. USD view is an interactive app, but the quit after startup flag, we can just time the startup and the time to first frame the DOM renderer. Yeah. Let's try that. Measure command. Yeah, that's what I expected. It's probably needs PowerShell, huh? So let's do PowerShell then, probably. Yeah. So it loads it. On the other screen, it's already displaying the application window. Then now it has closed, and now we have like the actual running time. That's about 14 seconds. Now, so to here you see now we're using PowerShell on Windows. I'm an old guy. I'm using still command the old shell, right? But we also can use PowerShell. And that's a built-in PowerShell thing, right? On Linux, anybody in Linux working? So we can like, does that work as well?
And
Maybe?
can't tell you just yet. I just started my OpenClaw on the
Okay.
Linux machine, so
Have you found the warehouse thing?
Yeah. I posted it here.
Ah, great. Yeah. See, yeah, that's kind of a real, like, lots of. And that's probably not using instancing with instantiable, but point instancing, which we're gonna see later on.
Can you just in one sentence explain the difference?
Here we have like in an explicit scene graph, and we say in the prim structure this is instantiable. With point instancing, you say I've got like this prototype, and I want it like I've got these 1,000 different points where I want to have this prototype appear, for example, right? And that's yeah, you'll see the difference.
Okay, good.
But it's if you have really lots and lots of instances, this is better.
Which what is better, point instancing or
point instancing? Yeah.
Okay. Yeah.
Great. So his guy was 27 seconds. So I'm mid-end laptop. I've got like a workstation, so it's 14 seconds. Makes sense. Yeah. Okay. Open instancing X graph toggle inst pi. Okay. Let's open that. I remember it. So instancing X S G author inst. I think this one is it, right? Toggle inst. Yeah.
Cool has a question.
Yes.
Hello, Cool.
Yeah, I have a question like, what's the difference between payloads and instancing?
Payloads is a different composition arc. That's two different things. Payload is basically you load a subgraph on demand. That's your payload, right? And instancing, you can use the instantiable using the payload, basically. You know, so
payload is injected from the outside, yeah, and instancing is happening inside your scene. Can I say it this way, Michi?
Yeah, it's just two different kinds of things, right? One is just loading and unloading a subgraph on demand, and instancing is like I want to like make a lot of same instances of a thing, right? So it's just. Can you guys describe it better? I can't. No.
Maybe I'll try and learn on the way. So if this is my scene, yeah, and then I can inject from the outside a payload, which is loaded on demand, yeah. And then when I'm inside the scene in here, I can call this payload and make it an instance, and then instance it inside the scene. So it's the way I see it as a non-programmer. It's called once into the scene with a payload and then instantiated inside the scene. Is that correct, Michi?
I think this slightly misses the main point of instancing.
Yeah.
Because the idea is not wrong, but instancing mostly helps you in saving storage and capacity, because you're displaying one element multiple times instead of saving separate instances for each of them.
See, here you could also write payloads, right? So it's basically just another form of specifying what's below here, but it's not relevant to the instancing, in my opinion.
Okay, but Julian, let's say I have 1,000 robots, yeah, in my scene, and each single one of them is using the same payload, so it's loading the same thing 1,000 times. Does it have it 1,000 times in memory then, or?
No, it won't, because instancing automatically detects the candidates. So
Okay,
it will
that's what
do
we
it
said before, yeah.
by default automatically, yeah.
Maybe I will say some words.
Yeah.
Payload is kind of similar to the reference. Reference can make you get the same definition of the original body, but payload enable you to define if this object should be loaded in this moment. And instance is kind of like make a copy of this, make a duplicate copy of this object. It will save the original document, the original body document, and replicate it in the same. So it's also have a similar binding to the original body, but it works differently. Yeah.
Yeah. Thank you for yeah.
Maybe some if I understand correctly, so payload is not loaded immediately, only when needed.
If you want it,
right?
Okay.
I would
can
call
specify.
payload a lazy load.
Exactly. So it's deferred, and the instance is a pointer to the original, but there is no need to copy the original.
Yes,
Yeah, for a
correctly.
programmer, the word copy is not ideal here. Yeah.
In Omniverse, if you check the property of the payload, there is a checker which you can enable or enable or disable this payload. So you can you can decide if this object should be loaded, should be shown in the stage right now. But referencing or instancing is directly every time will be rendered and will be showed in this scene.
So with the
yeah, it's a good point. But the deactivate you are referring to in Omniverse is just the deactivation of the prim, which you could do to any prim in the scene. But if you do it with the payload, then it's not even loaded. Like it's not even, the whole file for the layer is not loaded. Yeah.
Okay, and if how is there a mechanism instead of the human in the loop doing a checker whether it's being loaded or not, which is kind of annoying with 1,000 objects? How do I automate this? What mechanisms are there?
Script, for example, or can also switch it with a variant.
Okay.
Yeah.
So on that level, okay, I can, and then it's once I run the script or the variant, then it's loaded, and okay, I understand. Yeah.
And just try to also open it with Omniverse, which shouldn't be like where is it? I think that what was it? That guy, right? Scenario. Well, we won't see there are payloads as well here, so but it's just references. That's how references look like.
But you can change the reference to the payload, actually.
Right, let's do that. Yeah, good point. Convert references to payloads. So, what did it do? Did it do that? I don't see anything yet. Maybe convert references to payload. No, what I'm referencing is like, here. What is this? Let's use it a more simple example, probably, I'd say. Huh? Box palettes. Oh yeah, so here we have also, what's it, the yellow arrow? I haven't seen it. Have you guys? So here is the payload. That's the payload, for example, right? No. See? Yeah, that's what. Yeah. Never mind. This blue arrow is an icon for payload, right? And here, and this is the check mark to actually make the payload load, which is loaded here, and I can like click it, right? So now it's unloaded, so we don't have the subgraph here. I load it again, right? And that's not to there is like deactivate, but that is something else, right? Here, deactivate. That's on prim level. You can deactivate any prim. And then the prim is like as it's wouldn't exist basically, right? So yeah, because I think that was a confusion before between deactivate and payload. So here we have payload. Yeah, but just to I think that was that, right? What time is it? Yeah, I still have a little time. We had that, right? We did that. Yeah, we were looking into the code. Toggle inst in VS inspect code. What happens here? We pass our and we set component instancing. We get like our args, and what happens here? We open the stage, we traverse it, get the model API of any prim. We check, is it a component? If it's a component, we set the instantiable to the value of instance, which we set here in the argument, and by default it's 1, and we can set 0 or 1. Yeah, makes sense. So let's see what comes out of it. Let's run that. Something, yeah. With the one argument, the script now sets all component models in scenario USD to instantiable true. Let's open USD view to see what happened. And already like, and afterwards we will check in Omniverse as well, right? So I'll copy this. Open it. And still opens it. So let's see. Note that the component assets in the tree view now have light blue text. That's okay. So let's see. Let's see. We got it. Right. Light blue. So to see the legend, right? It's an instance now. Cool. So what did happen? Now instance is according to the prim legend. Yeah. Click the triangle icon, leftward world. Oh yeah, we just collapse that.
Warte.
Yeah. Click the try. So that just means basically this, right? We collapse it, right? Open it as well in our instancing scenario. So if we open that, do we see anything? Oh yeah, see. So the difference is not very much, but you see here this E, right, in the reference. That means it's an instance here as well.
And we still don't know what the yellow is.
We have to see.
Yeah. Which version from Omniverse are you using?
Oh, you tend to use always the newest, yeah. But
So
I'm not sure. 110 is basically I'd say, right?
Used, yeah.
Michael,
yes?
maybe you know this better. I found something saying that it's an instance proxy.
Uh-huh.
The yellow, you mean?
Yeah.
Ah, yeah,
Okay.
maybe, yeah. So yeah, so good. We'll dive into that. So now we know that, and it's 109.03. Right. Thanks. Yeah, great. I like how we interact. That's good. Yeah. Thank you for contributing. And so if the prototypes are not showing, you have to go through the setup. Enable show prototype prims among other settings. Yeah. Show prototype prims. Let's see. Show prototype prims. Yes. Prototype prims. I think, yeah, good, right? Undefined abstract prims, we don't have those, but let's show everything, right? So now we should be able to see anything. Okay. Yeah. See, the prototypes. Here we go. So that was meant by that. So let's. Here it is. Yeah, the prototypes. That's what the instancing did basically. And these are the prototypes, and these are all like then instances of the SCC, right? Instances, of the prototype. We should find basically a prototype of this, right? Yeah. See? Bulk storage rack. Bulk storage rack. Makes sense. So notice we already noted that all of the instances in the stage are based on 3 prototypes. Yes. Well, yeah. The bulk storage rack with just the pallet and the actual box. This is the basis for our prototypes. Click on the top left box closest to the camera in the viewport. Press F to frame.
Let's focus,
okay.
Yeah.
Let's focus on that. So I click on that and I press F. Yeah, it frames it. That's basically also the same functionality in Omniverse. You press and you press F, it frames it, right?
One question here. The icons that are on there, right? They are geometry there, right? The icons on the box, like on the lower right corner.
The sticker.
The stickers, yeah, that's basically a texture. Yeah.
No, is it a texture or is it geometry? Because
I'm almost certain it's a texture. Because you don't see anything.
Well, if you look at the other,
yeah,
there's like a frame around it.
Which one?
Wenn du im Dings da, yeah, here you see. That's what I'm wondering.
Yeah, that's a yeah. I'm not sure, but I think it's a texture. Yeah, still.
Okay.
But yeah, you can look into the geometry as well.
Yeah. Okay. Never mind. Yeah.
Right. Great. So we saw click on a triangle to the left of the selected prim to expand the selected prim's hierarchy. Note that its ancestors are dark blue. These are prims based on a prototype. Yeah, these are instance proxies. Yeah, makes sense. So let's click on that. We see that, right? Yeah. But I'd say this should be actually, which one is it here? See, yeah. This is what we selected. Yeah. Yeah, and this is basically as they said, this is a prototype. Referring to a prototype actually. So the prototype is this, right? And so what did it say?
Instance proxies.
Yeah, it's instance proxies, exactly. Yeah. So,
okay. So
basically, yeah.
In the chat, I pasted the OpenUSD reference to it. So can you open this in the chat?
Yes.
Okay. Can somebody explain that to me?
Maybe not now because
we don't have time.
We just wanna like finish our exercise.
Yeah.
If we may, because we're already over time and I have to leave for my the birthday party of my daughter. She's turning 18 and she's celebrating today as well. So I'd say
she has the same birthday to you as you?
Yeah, a few days before, yeah. It's yeah.
Nice.
A week before me, yes. Yeah. So but I think yeah we'll let's maybe just do this as a last step. So we finish basically this and see what happens if we get the same instances now. And then I really have to leave. Interpreter. Yes. Now we have instances, right? We have our prototypes. We have 3 prototypes. That makes sense. And yes, before we had like over 40,000, I guess, prims. Now we just have 1,700. So that's cool. And I'd say let's stop here and continue next week then. Right? All right. So thank you for your time. Good talking to you and have a nice weekend.
Nice weekend.
Bye, Mr.
Bye.
Have a nice
weekend.
weekend.
Oh, maybe I have some words to give you a feeling that difference between instancing and payload. For example, if I create an object, a prim, and I make it instanceable true, and I deprecate or I create an instance of this object for like 100 times, like 100 instance, and after this, I try to change the property of the original one. For example, I give it a new attribute or a new property like rigid body, for example. But the instance, the 100 instance, will not get the same rigid body. It will stay on the moment that you create the instance.
So that's a different to payload then, because if you make it a payload,
correctly, payload and the reference will like synchronize this like the changing what you made for the original prim, like immediately, even when you save this prim in another USD file, and you like drag and drop plug in to the current stage and make a payload, make a reference, it will get the same change, same like the newest, the current state of it. But instance will not. Instance will only remember in that moment you create this instance. And that's because I'm trying actually once, or I tried once to like instance a lot of screws, a lot of Schraube, and some of them I need to I want to make it have a rigid body, have a physical simulation, but I find the instance will not synchronize.
Picking it up.
Yeah, will not synchronize the same
Can I
effect.
force it? Can I force it?
I don't think so. In the Omniverse, the instance object or instance prim with the gray effect, you cannot even select it. You cannot even select the under hierarchy, the children prim under it. So it's kind of fix it.
But if you're on the USDA, you should be able to get access to it.
I don't think so. I find only the only opportunity or only Möglichkeit is you can move, you can make a new transform for the instance, like place it in another place, but in another place, rotate it. It's okay. Only for the transform or transform operation, transform op. But other operation like adding properties or changing the position, changing the values is not gonna be able to, or it doesn't work. So that is the
okay.
Maybe.
But what do I do if I? Okay, earlier I asked Julian, or I said I have like 1,000 robots, and they're all pointing to the same payload, or actually no, I import 1,000 robots, which all point to the same payload, so technically it's still always the same, and he said, well, it's gonna automatically figure out that this is the same robot, and it's gonna make it an instance.
Yes.
But then if I have certain limitations with the instance, as you said, that on the time of creation, it sort of freezes certain properties of that object or of that asset or prim. And if I'm not happy with that, what it did there, how do I change it? How do I gain back control? You don't know.
I think maybe you cannot change it. Another way to achieve this, maybe you can create a prim with different variant set, and you can choose which variant site, which variant you are like make an instance for that. When you're not happy for this instance, you can only delete it and make it a new from the other variant. That's the Möglichkeit, the possible way to achieve this. You cannot directly editing or changing the setting of this instance, unfortunately. So am besten, or just think it before, if this frame should be changed after a long time. If it's gonna be changed, then just make a backup or make a new version, a new variant for that, so that people can get it later. So
yeah, I have to get my hands dirty on that, I guess, because otherwise you
it's kind of difficult. I also tested in some scene and to check it, and and it's also different when you create a new frame in this stage and instancing this frame in the same stage, or you create in the same in another in the another file, and you instancing from that another file to this stage. Actually, it's kind of normally when I put another, I drag the another file into my scene, it will create automatically a payload. But if this file is set instancing or instanceable at true, this drag and drop will automatically being like create an instance, not the original file that I can edit or change or manipulate. So sometimes it's kind of you need to think it before that it happened.
Yeah.
And it's also different from the duplicate. When you click like Control and D to duplicate it, it's not instancing. It's create a new one, but same. So it's confusing sometimes.
Yeah. I've got to go as well.
Okay, then have a nice weekend.
Yeah, thank you. Bye.